Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, today I think we should practice more with stoichiometry. In my previous video, you had an introduction to stoichiometry. I really think we need more practice. So let's do it. Let's go to my screen. Okay, so we have to remember we have this map. We introduced it also last time. And this map is wonderful because you're going to follow where you are on the map. Let's say you might be with mass. And if you're going to mass of part B, you're going to figure out how to get there. So let's go to our first problem. Here is our first reaction. And we have, well, what type of reaction is this? Do you remember? We have our double replacement reaction. And it forms a precipitate. We have silver nitrate mixed with some copper chloride, and we're going to form a solution of copper nitrate, copper 2 nitrate, and silver chloride solid. So if we have 2.50 grams, if we add our copper 2 chloride into the beaker, the question is, how many grams of precipitate will we make? Well, how are we going to solve it? So let's go to our map, and we're going to start with mass of copper 2 chloride. Here is our mass A. And the question is asking how many grams of silver chloride we're going to make. So we have mass B. So from mass A to mass B, we have to go, change our copper 2 chloride to moles. Then we're going to use our mole to mole ratio and figure out moles of silver chloride. And then we're going to calculate mass of silver chloride. So let's do it. So we're starting with 2.50 grams of copper chloride. Let's change it to moles. We need our molar mass. So 1 mole of copper 2 chloride is 134.45 grams of copper 2 chloride. And our mole to mole ratio is, well, there is 2 moles. 2 moles of silver chloride is made for every 1 mole of copper 2 chloride used. And then we have to have a molar mass of silver chloride. Molar mass is 143.32 grams of silver chloride per 1 mole of silver chloride. And we plug this into a calculator. And remember, we need 3 sig figs. And we're going to get 5.33 grams of silver chloride. So how did you do? Let's go to the next problem. Here we have, what type of reaction is this? Do you remember? It's double replacement and it's acid-base reaction, right? We have hydrobromic acid reacting with potassium hydroxide. Yes, acid plus base makes water and salt. So the question is, if we have, let's do 3.80 grams of our potassium hydroxide, how many milliliters of water will we produce? Right? So let's first figure out how many grams of water, and then we're going to use density of water to figure out milliliters. But this question then is very, very similar to the previous question. The plan is to start with mass mass of our potassium hydroxide, going to change it to moles. Then we will change things to moles of water, grams of water, and then we will use density of water to figure out the volume. So that's the plan, and let's go. So let's start. 3.80 grams of potassium hydroxide. Let's figure out our molar mass, change it to moles using molar mass. So we have 1 mole. Potassium hydroxide is 56.1 grams. And now let's do our mole to mole ratio, where there is 1 mole of water, H2O, made per every 1 mole of potassium hydroxide used. And molar mass of water is 18. There is 18 grams of H2O per 1 mole of H2O. And then density of water is 1 gram per ml. So I'm going to say 1 milliliter is per 1 gram. And if we plug this in to a calculator, now remember we have to use sig figs, also 3 sig figs. We're going to have 1.22 milliliters of liquid water, H2O of our liquid water produced. Here we go. You ready to keep going? Let's go here. Our next problem. We're going to put some magnesium ribbon into hydrochloric acid. Okay, now let's crank it up a notch. Let's make it a little bit harder. And what type of reaction is this? Do you remember? So it's our single replacement, and it's a redox reaction. So the question is, if I have magnesium ribbon, that's 2.75 grams, how many milliliters of gas will I produce? And I'm asking how big will my balloon be? And this will be at STP. So where are we and where are we going on the map? So let's quickly go to our map and figure out. Okay, so we're going to start with grams of magnesium. We're going to change it to moles of magnesium. Then we're going to go to moles of hydrogen gas. And then we're going this way to volume of hydrogen gas at STP. And the conversion factor will be 22.4 liters per 1 mole. So let's go and solve this problem. Okay, so we're starting with 2.75 grams of magnesium. Molar, let's change it to moles. Molar mass of magnesium is 24.3. Okay, let's keep it down here. So 1 mole of magnesium is 24.3 grams of magnesium. And now we do our mole to mole ratio, and it is 1:1. So 1 mole of hydrogen per 1 mole of magnesium. And now we're going to change it to, we have 22.4 liters of hydrogen per 1 mole of hydrogen. And the question is asking how many milliliters. So we're going to do times versus 1,000 milliliters in 1 liter. So we plug this into a calculator, yes? And the calculator says we have 2,530 milliliters. That's a lot of milliliters, right? So if we do change it to liters, in case you want to know, that's 2.53 liters. And I'm using 3 sig figs because the question has given me 3 sig figs to start with. Okay, how did you do? Let's go to the next question. Here we go. We're adding copper wire into a solution of silver nitrate. What type of reaction is this? It's our single replacement redox reaction. Let's practice a little bit. And the question here is, if I put 56.7 grams of copper into solution, how many grams of silver metal will I get? So this is also, remember our map? Very straightforward. You're going to start with your grams of copper, change it to moles of copper, to mole ratio, moles of silver, and then grams of silver. So let's do it. So we have 56.7 grams of copper. And what's the molar mass of copper? We need our periodic table, yes? So 1 mole of copper is 63.55 grams of copper. And now our mole to mole ratio, we have 2 moles of silver is produced for every 1 mole of copper used. And molar mass of silver, we have 107.87 grams of silver per 1 mole of silver. And we plug this into a calculator and we get 192 grams of silver can be made if we put 56.7 grams of copper into the solution. Okay, let's keep going. So, we're making table salt in the next question. What type of reaction is this? We have our synthesis reaction and our redox reaction, yes? We are making table salt from our metal, non-metal, making an ionic substance. Okay, so here is a question. Let's make it a little bit harder. If I have 5 liters of chlorine gas, 5 liters of chlorine gas, how many grams of table salt can I make? Now I have unlimited supply of sodium metal, so that does not matter here. So I have 5 liters of chlorine gas. Well, do you remember how we have to go to our map? Yes. And I am starting with volume of chlorine gas. I need to change it to moles of chlorine. Then I need to change mole to mole ratio, how many moles of salt. And then I'm going to go to how many grams of salt. It's my substance B. So let's go to our problem right here. And let's start. So if I have, and then we also are, just remember, at STP, standard temperature and pressure. So if we have 5 liters of chlorine gas, we're going to change things to moles. So I have 1 mole of chlorine gas is what? 22.4 liters. And now I'm going to do my mole to mole ratio. There is 2 moles of sodium chloride per 1 mole of chlorine gas used. And my molar mass here is 58.45 grams of table salt per 1 mole. And we plug this all in a calculator, and we're going to get that we can make 26.1 grams of sodium chloride of our table salt. If we start with a balloon, that's 5 liters of chlorine gas. And last question. Let's do another type of reaction. Do you remember what it is? It's a combustion reaction, yes? Carbon-containing compound reacting with oxygen, making CO2, carbon dioxide gas, and water. So our combustion reaction, it's redox, yes? So let's start with, if we have 20 liters of propane gas at STP, we want to know how many milliliters of liquid can we make, of liquid water can we make. So that will be our question. Are you ready? Do you remember the map, how to get there? So we're going to start changing things to moles. So let's do this. So we have 20 liters 20, so here 20 liters of propane. And we need to change it to moles, right? Conversion is 1 mole of propane of any gas is 22.4 liters. Now we're going to do our mole to mole ratio, yes? And there is 4 moles of water produced for every 1 mole of propane used. And we have molar mass of water, 18 grams. 18 grams of H2O per 1 mole of H2O. And we want to know how many milliliters, so we're going to also use the density. Density of water is 1 gram per ml, so I'm going to say 1 milliliter per 1 gram. And you're going to plug this into the calculator. Let's plug this in. And remember 3 sig figs, and we're going to get 64.3 milliliters of liquid H2O can be made. So how did you do? Could you follow along? Or maybe could you solve this before I did? I hope this practice helped you become a better chemistry student. And see you next time.